Michel Gifford's Baptiste Camion and Jules François for my thesis entitled Construction of Model Behavior by Novices through Interaction with Machine Learning. Nowadays, machine learning systems mediate our everyday lives in many ways, from what we see on social media to whether we get hired by a company or whether we can access a loan. And these models are usually optimized for goals like accuracy or sometimes fairness. But the way that they behave in real world, it can reproduce inequalities that sometimes can cause serious harm. For example, some years ago, Amazon deployed a hiring system that later it showed sexist behavior because it was consistently filtering the women's resumes. So eventually the company had to completely shut down the tool. Or an official report on the Compass risk assessment tool showed that it assigns higher risk to Black defendants rather than white defendants, even when they had similar reports. Or in another example, YouTubers found that the YouTube algorithm demonetizes queer content, so queers would get not the visibility or the income that they have to. These outcomes matter more than isolated machine learning failures because, as I showed, they have real impact on real world. They shape opportunities, resources, or how we are treated in youth. So it's important how we evaluate these models. But when these systems are developed in labs, they're usually evaluated with metrics like efficiency, accuracy, and sometimes fairness. But these quantitative measures are too narrow to capture how models actually behavior when they are in use. So this is why recent research emphasized that we should study machine learning systems as machine behavior, which means we should look at how they act and interact with users in practice, where their behavior actually unfolds. And this is where at the intersection of HCI and machine learning, the field of human-centered AI offers a critical insight that instead of seeing models as autonomous decision makers, HCI focus on the people who interact with them, and it emphasizes on including their needs, their values, and their practices. So from this point of view, HCI explores how we can design and evaluate machine learning systems with a focus on understanding and foregrounding human values. HCI identifies two major areas where these human values can be incorporated into machine learning systems. The first focuses on the design and evaluation of models in the lab, and it explores how we can involve those who are mostly impacted by these systems' behavior to better understand their needs and values. And the second one is ethical AI, which examines the questions of values, fairness, and power of machine learning systems when they are used in the world. And it asks questions like whose values are embedded in these systems or how does it impact people. But in both of these approaches, people are not directly involved. They are treated as data providers or participants in research or in workshops. So still much of the power remains in the hands of experts. And so people have no real agency over how the model should behave at the end. And that's why recent work in HCI calls for restoring user agency. And it suggests that we should combine these two strands of research. So the ethical questions are not just asked by experts, they can be asked by users when they're involved during the design and evaluation of these systems. From this view, HCI emphasizes interaction with AI system, and it offers a focused lens on how people interact with machine learning systems so that we can align what people want from these models to how the model actually behaves, so that they can surface their values, highlight ethical questions more dynamically instead of just static inputs. And to do this in my thesis, I propose that we should find ways to involve users directly in the development phase when the model is under design, and also in the post-deployment phase when it is in use. But in these interactions, it is also important to ask who needs to be involved to shape and evaluate model behavior. In my thesis, I focus on novices that have no machine learning expertise, but they have valuable lived experiences. And these are end users or those who are directly subject to the model decisions, and they are very often left out of formal machine learning design and evaluation. So from this, I study how novice users contribute to the construction of model behavior through interaction with machine learning models, specifically during development and post-deployment phases. So in each phase, I examine a form of interaction between user and the model that I will present in the next section. In the development phase, I examine how users can collaborate to shape model behavior together, that I will present in the first section. And in the second phase, I examine how novices make sense of model behavior so that they can evaluate this behavior, that I will explain in the fourth section. And at the end, I revisit my contribution and the broader points of discussion in my thesis. Engaging users throughout the machine learning development has been primarily the focus of interactive machine learning that engage users in an iterative feedback loop so they can label data, test outputs, and correct mistakes. And the main focus here is on what model learns in this instruction. Then the field of machine teaching shifted the focus from what model learns to what human can teach. So here human take the role of a teacher and model become the learner. So the teacher can go beyond just labeling data. They can actually design a teaching strategy to convey their domain knowledge to the learner. And then interactive machine teaching builds on both of these paradigms. So it combines the real-time interactive feedback of interactive machine learning with the pedagogical and teaching strategies of a teacher. And interactive machine teaching, they consider three main activities for the teacher. The first one is explaining activity that the teacher labeled the data and decide what to teach to the model. Then there is reviewing activity that the teacher inspect what model learned and inspect the model prediction, errors, etc. And then there is the planning that they iteratively try to decide what to teach in the next iterations. So they come up with a teaching strategy. And the focus of interactive machine teaching here is on model building with the specific role of the human as a teacher. But so far, this interaction has been studied only in individual settings. So in my first study, I investigate how teachers can collaborate to teach the model, which I explain in the next section. Then the post-deployment phase, a common approach to evaluate machine learning systems in use is algorithm auditing, which means to probe models' output to uncover how it behaves, especially when the behavior is biased or harmful. But most of these audits are led by experts and they miss everyday context of use or the user's lived experiences. And this is where user-driven algorithm auditing shift the focus to end users themselves, because recent cases show that users, by directly interacting with the output of the model, they can surface problems in more situated context. And this makes auditing not just a technical check, but a sense-making process, which I studied in my second user study. Now I go back to the development phase and I explain my first study on collaborative interactive machine teaching. As I discussed earlier, for involving users directly in the development phase, interactive machine teaching has the potential to engage users. So here it considers the role of the user as a teacher, and in tight interaction, the teacher can bring values and teaching goals so that ultimately they can shape model behavior. And recent research in this field has shown that novices has the ability to shape model behavior with various objectives, such as providing diverse training data or caring about reducing bias. But most of the works are focused on single user interactions, which means the model behavior reflects individual perspectives. But this raises important questions about how diverse viewpoints can be brought into the model, or how we can have systems that support collective construction of model behavior. But more importantly, we also should ask who gets to shape machine learning systems. The field of participatory AI answers this by acknowledging that communities have valuable knowledge, expertise, and lived experiences, so that we should focus to include these collective values and communities' perspective into designing machine learning systems. And it provides several works, but mostly they are focused rather on collective data curation or collective decision making. But in most of these works, there are still shortcomings, but because still users have limited agency over the full model development, and most of the contributions are happening in parallel, so there is no negotiation or dialogue between users. And also there is the risk of participatory washing, that mostly users are involved as consultants rather than having the agency or power over the model. This is why recent research in this field emphasizes that we should empower communities, and this requires that we should involve them across the full machine learning life cycle and with shared control. And this is exactly the motivation for us to propose collaborative interactive machine teaching. So in this approach, we believe that teachers should have ways to explain their knowledge, to negotiate with one another, and to develop a shared understanding of model behavior, because this turns model development into a collaborative problem-solving task. And it's through this collaboration that teachers both maintain shared control and also across all the stages of the process. So in the rest of this section, I first explain how I extended interactive machine teaching into collaborative workflow. Then I will explain TeachTech, which is the first collaborative interactive machine teaching application we designed and deployed. And then I will explain the user study we ran with this application, and then our findings and design implications based on our findings. So in a collaborative interactive machine teaching workflow, a group of teachers interact through diverse interfaces tailored to their roles. This feature is required because in many real-world teams and collaboration, the expertise is distributed among team members. And then they have access to a shared data set, which allows them to collectively curate teaching examples and explain it to the model. And then they have a shared model, which they can collaboratively review its performance. These shared data set and models are essential because they are shared object in a collaborative workflow, so that teachers can build shared understanding based on objects. And finally, they use a communication tool to discuss their objectives, coordinate strategies, and deliberate on all teaching activities. Then for setting these collective interactions, we designed TeachTech, which is a web-based collaborative interactive machine teaching application for image classification, and it's specifically dedicated to machine learning novices. So TeachTech introduced a collaborative workflow, and it combines several novel features to make happen this collaboration. First, a group of users have access to a shared dashboard, so that it allows them to see the collective performance of their collaboration, for instance, the accuracy and the number of classes they achieve over time. And then they have access to a Teach tab. Here they can upload any image that they want to teach the model or decide to teach the model, and they can see the predictions of model on this image, so then they can decide to teach this to the model or not. When they upload these images, first they build a personal data set, and then a personal model will be trained on this personal data set. Then they can decide to share this data set with the whole group and update the collective model. When they do that, they can, so their data is going to a shared data set. Here they can see all the data curated by all the team members and also their own data, and they can remove or edit their own data. And then they have access to an inspect prediction tab. Here we have visualizations that give users direct access to the model's errors. So the first is a confusion matrix that it shows where the model fails or confused between two categories. And then on the bottom, it lets them to inspect each instance and see the confidences on each instance separately. So through this, they can view the model's errors. And at the end, they have access to a chat tab. Here, they can share their insights over the model's performance, and also they can exchange comments. Then with this application, we conducted a user study in which 3 teams competed for 9 days, and their task was to train an image classifier to recognize 10 dances styles. And their objectives was to achieve the highest accuracy as possible. Then after 9 days, we ran focus groups separately with each group that this provided the qualitative data for our analysis. So for data analysis, we did mixed methods of both quantitative and thematic analysis on our focus groups. I'm going to present only our qualitative analysis results. So first, we observed that each team coordinates the task differently. For instance, one group just distributed the categories among members. The other group assigned different roles to each team member. For instance, one of them was in charge of just providing and curating a teaching data set, while the other was trying to review the model's performance on this data set. And then the first group didn't collaborate explicitly, but they had implicit collaboration that they could see each other's contribution. They were trying to fill the gaps. So from this, we realized that in a collaborative workflow, we should let users to be flexible about their roles and to negotiate their roles collectively. And also we might need to provide them flexible interfaces tailored to their roles. But although we saw different task coordinations among teams, but at the end we saw that all teams collaborated on the planning activity. And this collaboration helped them to revise a collective teaching strategy. For instance, in one of our teams, one of the members realized that the model, the training data, the teaching data for the ballet class for the model is mostly female dancers with white dresses. So whenever they were providing an image with white dress, it would predict its ballet. So then she informed other team members that we should think about diversity in the data set. So then others tried to provide a more diverse data set, like providing male dancers or with clothes with different colors. So through this, they come up with a collective teaching strategy to care about diversity and more varied representation. And from this, we realized that we should let participants negotiate teaching objectives in a collaborative workflow. And also in our focus groups, some participants claimed that they wanted to know, for instance, in the same group that they were caring about diversity, they wanted to know they wanted to know the diversity level from the model's point of view. So maybe we should let participants to negotiate what performance metrics they want at the end. And regarding interactions with teach tag, we observed that participants reflected on the teaching task through individual interactions. For instance, in the Inspect Error tab, they could explore the confusion matrix to see what categories the model confused or see the predictions for each instance, and they did this mostly individually. But then they use the communication tools to deliberate with each other over their individual observation, like the same group that I explained. But in our focus group, they asserted that they required more discussion on all teaching activities, including on the data curation, on labeling, on reviewing, etc. So we might still need to improve our communication tools to facilitate more discussion on all the teaching activities. But our works also had its own limitations. For instance, our sample size was limited to 12 participants, and they were mostly have similar backgrounds. But in real world, the collaboration might happen among more diverse populations with different expertise or area literacy. And also, our study was conducted during a short time. And if we run the collaboration a longer time, we might see how dynamics change in their roles in how the collaboration sustains or how the objectives and understandings evolve. We also set the objective as higher accuracy, although we know that it doesn't capture the whole quality of the model. But we saw that participants came up with more objectives in their teaching strategies, but still we might have foregrounded their focus on accuracy rather than more social dimensions. So from this limitation, we motivate future work to run more longitudinal and domain-specific studies in community-led contexts. But we believe that collaborative interactive machine teaching can situate itself within participatory AI, which advocates for greater involvement of communities, because this is the same aim of CIMT as well. And they both reflect on a shared goal to bring machine learning systems closer to people. But unlike most of the participatory AI that they usually limit the user agency, in collaborating target machine teaching, the model training is accessible to the users through all the cycles of the development phase. So the development phase becomes more inclusive and community aligned. We also observed that at the end, the model behavior became a collective, situated and negotiated outcome. But more importantly, we observed that participants reflect on deeper concerns about what the model should learn to, for instance, include diverse viewpoints, or they care about bias and fairness. And this happened mostly during the reviewing process. In reviewing process, participants were probing the model outputs, and this mirrors the key elements of the post-deployment evaluation. So our work was kind of a bridge between development time engagement and post-deployment critique, and it motivated us for our next user study. So second user study, we investigated sense making in user-driven algorithm editing, because we observed that when users interact with the model in the development phase, they can surface values and concerns about bias, diversity, representation. But we are aware that with nowadays large language models, we can't always afford such interactions. This is because these models are massive pre-trained black box systems, and so end users have no mechanism to correct or refine these models. So in this context, model behavior must be interpreted through interaction with outputs after deployment. And this is exactly what user-driven algorithm editing explores. So this will expose how end users can surface harmful behavior according to their values by probing the model's output, as I discussed earlier. But these outputs are not often generated with full transparency. So, and mostly users are left to interpret them without any support or explanation. And this is why recent research in user-driven algorithm editing got interested to see how end users can uncover and interpret these biases and harmful algorithmic behavior. And they propose that at the core of user strategies, there is an iterative interpretive process that users try to understand and evaluate the model's behavior. And this process is called sense-making stage. And this research emphasizes that sense-making stage is specifically influenced by the platform affordances, because this platform lets users they shape what user can observe, explore, and compare. And it kind of becomes a site where their understanding evolves through time. And this is why there is a recent interest to design editing tools that are tailored to end users, but still there are not that many tools to support sense-making process. And also there is no systematic investigation on this stage, and its alignment with platform affordances. So based on this, we got interested to study how interface design can support Novices sense-making in user-driven algorithm editing. We first conducted an experimental study in which participants edited an image capturing model for gender bias. This was our context that I will explain next. Then in the rest of this section, I give a detail on the study design and experimental conditions. And then, First, I explain the editing interfaces we design that are grounded in sense-making. Then I will explain the between subject study we ran with these interfaces, and then our findings. So to investigate our research question, we studied editing of occupational gender bias in image captioning, because recent literature on gender biases in image captioning showed that experts found many gender biases in these models. For instance, one of very famous is a stereotype exaggeration that, for example, it consistently assigns doctor to male and nurse to women. Or another example is gender activity binding, that with same setting, same custom for different genders, it has different outputs. For instance, for male police officers, it explicitly says two police officers walking down the street, but for a woman, it says there is a woman walking down the street with a gun, instead of assigning the occupational role. So based on this, we got interested to see if novices can find these gender biases in the model or not. And to do that, we first design and develop an editing interface grounded in sense-making processes. We grounded our work on a recent sense-making framework that explains how AI practitioner makes sense of machine learning model behavior, because this is the core of user-driven algorithm editing as well. But in our work, we study how we study novice strategies in this sense-making process. This framework first explains that people first explore the instances and outputs of the model behavior. Then they try to organize these instances based on similarities in the behavior of the model into groups that they call it a schema. Then from these schemas, they make a hypothesis about the behavior they observe, and then they try to find more evidence for their hypothesis. And eventually, at the end, they reiterate on their hypothesis, their findings, to summarize their findings to come up with an assessment of model behavior. And this process is iterative and non-linear, which means that a user can enter the sense-making from any of these stages. whether from predefined schemas or initial hypotheses, and then they reiterate the stages of the sense making. So we design our auditing interface to scaffold these key stages of the sense making process. Now explain our interface. This is the main dashboard of the interface. In the left part, they had access to a dataset explorer that they could inspect each image and see the caption generated by the model in the center. So they could freely explore the whole dataset and model's captions. Then on the right side, they could make bias cards. These bias cards are for documenting their observations. So for instance, if they observe a bias in this image, they can first write a description about the bias they observed and in what conditions, for instance, it happens. Then they can drag and drop the images and their captions as a supporting example. So this box in the bottom would work as a way to help them to make their schemas. And then at the end, they were submitting all their bias cards as their auditing report for us. And they could make as many bias cards as they wanted. But because our task was to audit image capturing model, and it involves examining the relationship between images and their captions, we designed also two additional tools specialized for each of these modalities. And these tools were designed to support different sense-making strategies that we had already observed in prior work in user-driven algorithm editing. And the first tool was an image masking tool, which was to let users to manipulate single inputs and to compare how the model's output would change based on this. So in our case, on the center, on top of the image and the model's generated caption, they had access to a brushing tool that they could mask any part of the image that they wanted, and then they could see how the caption changed based on these modifications. Then for the second auditing tool, we designed a text filtering tool, which was for comparing multiple outputs in parallel to detect patterns of bias. In our case, it would be on top of the dataset explorer, they could input any keywords they wanted. For instance, they could enter woman keyword, and then the dataset would filter the images based on to show just images that have the word woman in their captions. And they could enter multiple keywords, which was operating as an AND operator. So here they input both woman and doctor, and these are images that in their caption it mentions woman and doctor. And then they could also remove any keywords to expand the data set again. Then with this auditing interface, we did a user study to audit the sales public model for gender bias in medical context. And we provided 80 images from Visa Gender dataset, which is a well-known dataset for studying gender bias in image capturing models. We hired 60 participants from Prolific, mostly individuals that had no prior experience in auditing or any formal education in machine learning. Our demographics for the age, they were from 22 to 65, and they were gender balanced and quite internationally diverse. So we ran a between subject study with three conditions. The first condition, they had access to a baseline interface. In the second condition, they had access to baseline and the image masking tool. And for the third, they had access to baseline and text filtering tool. So for the whole study, first, we asked them to fill some pre-study questionnaires to capture their demographics, and also we provided them ASI questionnaire, which is a questionnaire for measuring their prior gender attitudes. Then we ran the main task for 30 minutes that they had to explore the data set, find gender biases, and use our bias cards to document their observations. And at the end, they had to fill a questionnaire that, for example, we asked them to to rate how much confident they were on each of their observations. Then for data analysis, we did a mixed methods of quantitatively we analyze the number of bias cards in each condition for each participant, and then the number of evidence for each observation for each bias card, and then their self-reported confidence and the correlation of confidence and the number of evidence they gathered. And qualitatively, we did a reflexive thematic analysis of bias cards, specifically on the descriptions that they wrote about the bias they observed. And then we did a comparative analysis across conditions to see quantitatively how teams are distributed among across conditions, and also qualitatively how the sense maker strategies. So again, I mostly explain our thematic analysis results. Our thematic analysis of bias cards showed that users surface many kinds of gender bias. Specifically, they covered all the biases that were already reported by the experts in the literature. That we characterize these gender biases into four main themes. The first one was that the mother reinforces gender professional stereotypes. Then the second theme was that the mother's emphasis on gender leads to and also reinforces the stereotypical role assignments. And the third one was that the mother's use of visual cues reinforces the stereotypes. And the fourth one was that the mother's language reinforces gender assumptions. I will explain the second theme in detail. So in the second theme, participants, they observe that the model describes women by their gender instead of their professional role, but for men, it mostly labels them by professions, specifically by doctor, and they believe that this reflects the assumption that mostly men occupy professional roles. Then they observe that even when the model foregrounds gender, it also sometimes infers this gender wrongly. And then they observe that it's because it relies on a stereotypical visual cues. For example, if a woman had short hair, it would refer to it as a man. Then from all these observations, they got curious to see how model performs in mixed gender settings, and observed that in this context, model consistently assign the authority to men, even when the visual cues shows the opposite. So for instance, in this example, they observe that the model overlooks the professional role of the woman and it assigns patience to her as well. Then in our quantitative analysis, we observe a significant association between interface and team distribution. So it shows that each tool scaffolds attention toward the specific patterns of bias that I explained some of the examples now. For instance, in condition 2, participants could mask input features such as face, genders, or equipment. This led them to a set of fine-grained tests. So they could explore how much the model is sensitive to what visual cues for inferring roles and genders. For example, in this example, they masked the face of the woman and they observed that the model assigns doctor to the man instead, despite it's clear that the woman is a doctor here. So from this test, they realized that the model is actually mostly sensitive to gender inference for role labeling rather than other visual cues. So based on this test, this condition led to a higher number of bias cards in 3 that the model focus on stereotypical visual cues, but also they had observations on role attributions such as men are doctors, women are nurses, or how the authority is good toward men. Then in condition 3, the filtering tool helped participants to retrieve and compare subsets of image caption pairs. For example, they could use gender-related keywords, which made it easier to spot linguistic asymmetries. For example, they could compare the proportion of captions that refer to a woman as a female doctor and to a man as a doctor. And they hypothesized that this might happen because the man seemed like the default in medical settings. So it mentions the gender explicitly for the female doctor. So this tool helped them to frame language both as descriptive, but also as a mean for implicit assumption about gender and competence. But filtering tool also helped them to quickly verify hypotheses about role attribution. Because, for instance, in some cases, they filtered the data set based on the woman and doctor label, and they observed that even when the woman is clearly a doctor, the caption is still assigned the doctor label to someone else. So it says a woman in white coat talking to a doctor. But based on our results, we realized that we saw that all the bias patterns were reported by experts in the literature was captured by our novice participants. And in literature, these biases are mostly scattered by our participants found all of them in their editings. And besides that, they also reported precise circumstances under which these biases happens. And sometimes they show that how multiple bias mechanisms interact with each other. So they show that these biases that just they don't appear separately, they reinforce each other. And we also observe that interface design shapes what becomes visible and actionable. For example, the masking tool led participants to focus on visual cues, while the filtering tool, they were mostly focused on linguistic framings, and which contributes to how tools can support sense making in different ways. But also we observed that sometimes participants had contradictory hypotheses. For instance, in a case that the model would mention the doctor, some of them hypothesized that it's because the man is the default, so it reinforces the man authority in medical context. But some of them hypothesize that when the model says female doctor, it means that the woman is the exception. So the use of gender adjective here is to show that exception. So from this, we realize that auditing can become a collective sense making. So that these varied views can be a space for multiple values instead of just individual interaction. But our work also had some limitations. For instance, we provided predefined data set and tasks, which might hinder people from finding more intersectional biases. And also we still have unanalyzed data on action likes and our demography and ASI questionnaires on gender attitudes to align them with the audit reports. And also our study was a controlled individual setting, which is not the case in the real world. In real world, there are more situated contexts that users use these models. And also they might be in social medias that are they can interact with each other. So from this, for future work, we motivate to accommodate multiple cultural standpoints for situated and collective auditing. So my thesis builds on a human-centered AI perspective to examine how novices construct model behavior through interaction. In the first study, I introduced collaborative interactive machine teaching, and I developed TeachTalk, and I showed when users use TeachTalk, they can curate data, inspect prediction, deliberate together. So I showed how a group of novices can train a machine learning model collectively, and I showed how model behavior in this setting became a collective negotiated outcome. Then in the second study, I showed how users edited gender bias in an image capturing model. So they use three interactive interfaces that we designed based on sense-making process. And we showed how editing interfaces how user-driven auditing first revealed a rich description of many different biases, and also how interface design shaped what people noticed and how they interpreted these biases. So based on this, through these two studies, I contributed two tools dedicated to novice interactions with machine learning models. And I conceptually also introduced collaborative interactive machine teaching as an extension of interactive machine teaching that reframed model training as a shared negotiated process. And also I provided a sense-making driven design of editing interfaces. And finally, my two studies contributed to empirical findings of how model behavior can be constructed through users' interaction with machine learning models. In the beginning of my presentation, I discussed that we can't fully understand and evaluate machine learning models by just performance metrics, and that recent research suggested that we should study machine learning system as machine behavior. And based on this, in my thesis, I studied that model behavior actually emerged through interaction with users. And through two studies, I showed that novices can do more than just observing and evaluating this behavior. And they can, so for instance, in the first study, they negotiated and revised teaching strategies that ultimately shaped the model behavior. And in the auditing study, they iteratively tested and refined their understandings. And they hypothesized about how the model should behave in certain ways. So they weren't following a checklist of failures. And this is what I mean by construction of model behavior through interaction, because it's not just about providing inputs or observing outputs. And I believe that in a human-centered approach to machine learning, we must support users to interpret, question, and negotiate how the model should function. So we should try to make model behavior interpretable, open to critique, and also responsive to people who interact with it. And my thesis was not framed as a participatory design, but it offers insights for participatory approaches to machine learning. First of all, the tools that I provided shifted the focus from performance to questions on social implications. And across both studies, the tools enabled more than just feedback of the users, because they could go beyond consultation and they actually had agency in shaping and evaluating the model. But both of my studies were short-term and controlled, so I believe in future work we should embed these tools in a more participatory real-world setting and also over longer time scales. And also in both of my user study, we did not surface how user perspectives, including their identity dimensions, for instance, their gender, their race, their cultural background, may have influenced what they choose to teach, what they perceive as bias, or how they interpret harm. And I believe in future work, we should build on more reflective and first-hand engagement. For instance, we can use feminist approaches to machine learning that actively foreground positionality and the perspectives of those who are mostly impacted by machine learning systems. Thank you for your attention.
Thank you, Behnoosh. So we will now go into the question and answering phase. We will start with the two people who reported on the Facebook. So and wrote an evaluation. And I will start with Simone, who's a professor at the University of Glasgow, and she's the person that's furthest away. Take it away. Thank you.
Great. Thank you. I
Just 1 second.
yeah.
Technical support. Yeah, you can go ahead. I think everyone hears you well.
Thanks very much, Behnoosh, for providing your thesis. I read it obviously in detail, and also your presentation, which gave a really nice summary of the work that you did. I have 15 minutes for questions. And I will start sort of from the beginning of your thesis and then work my way through with my questions. So I think in the beginning of your thesis, you sort of emphasize the real world use that is important, and also the non-metric kind of assessment or evaluation of this. Can you just explain perhaps how that sort of affected the studies and the way that you measured the studies? Kind of how did that affect the studies that you actually did?
Non-metric fairness.
Yeah, so you know, the non-metric conceptualization of fairness and also the real world use of it.
I think it informed many things. I know that in my both studies, the studies weren't in real context, and but we couldn't just jump to exploratory study, I don't know, in a social media and see how people interact with the models. We needed to design interactions that could help them. So we were mostly somehow simulating a very controlled way of those interactions that we can measure things, we can see strategies, etc. So this is why it wasn't in real world context, because we needed to be controlled and very narrow in what we measure, what we see. For the non-metric fairness, I think the first study we didn't use any fairness metrics. We used accuracy, but we wanted to see how non-metric fairness would emerge from users' interactions. And it happened because the objective was accuracy, and what we observed that first I think the to meet participants started to question accuracy, the definition of accuracy. So for them, it wasn't to maximize the accuracy. Then they observed that the model doesn't recognize diverse data. So then the definition of accuracy for them changed, and it led them to fairness, diversity, and etc.
Mm-hmm. Okay. Thanks for that. So the first study deals with collaborative interactive machine teaching, which I guess your unique contribution is the collaborative element of interactive machine teaching, right? And so one of the things that I was wondering was, so you had 12 people in 3 teams?
Mm-hmm.
Okay, so four people per team. You also had a couple of dropouts, right? Were they both in the same team?
Yes, we had 2 drops out from one team and 1 dropout of another team.
Okay, so you ended up with a team of 4, a team of 3, and a team of 3. Okay.
A team of 2.
Two.
Yeah.
Hold
2,
on.
3, 4. Mm-hmm.
Oh, so there were 3 dropouts? Oh, all right. Okay. So my question is firstly, do you think the dropout affected the team performance and the way the team operated? And then second question is the different strategies, the different themes that you described. do they lead to different team performance as well? Right, where I mean, it's partly a question. You know, the team of two was their performance in the end related because it was a team of two, or was it related to strategies?
I think both probably, because in the team of two, they had the least accuracy, and they weren't in the sense of the definition of collaboration. They weren't collaborating; they were cooperating because they didn't do all the tasks aligned with each other. One of them was data curator, the other was data reviewer. So that might be the effect of their strategy on the performance. But also I think if they were four, at least maybe they were more collaboration in each role. So we might have seen another performance. And on the other hand, the team that they were four and they were collaborating really on most of the teaching activities, they gained the highest accuracy.
So do you think it is, you know, part of your results is that actually we need to encourage this collaborative element, and it actually doesn't matter what size the team is, or do you think that holds up, and did you do any analysis around that?
I think it's the size of the team is important in terms of have the collaboration that might happen. Like in a team of two people, the collaboration might not happen. So as much as we increase the number of participants, it would align with more collaboration. But I think they're not. It's not directed to the. No, it can be directed to the performance in this.
Yeah, I mean, you know, with you know, in effect, you only have two teams that you can draw any conclusions from, because the team of two is relatively small, right? So I think, you know, there might be something there, but, you know, proving it might be different from the data that you have. Okay. Right. Let's turn to the second study, which is on user-driven auditing. So you explained that it was driven by the sense-making process model, right? And I guess Cabrera has developed some tools as part of their study. So how do these tools that were developed in that previous work, how do they relate to the tools that you were developing?
I think the input manipulation tool, they had it also in another way, just as a way to let users to test the inputs for the model. So it was the same, and also it was the same strategy in user-driven algorithm team. That's why one of the strategies that we choose, one of the designs that we choose was this, because it was both motivated by user-driven algorithm writing and also the sense-making tool that Cabrera developed.
Okay, so could you perhaps go to your tool?
Which
the auditing tool. Okay.
This one.
Yes, this. So which bits come from Cabrera, and what kind of sense-making stage does it support?
Each of the tools. Yeah.
Yeah.
Each of the feature stage. So the bias cards was a tool to help them to for the hypothesis and also schema creation. In Cabrera, they come up with the affinity diagram for the schema so that they would be freer in making clusters and everything. But we realize it's a bit complicated for our novice users.
Mhm.
So we reduced it to a box that they could just drag and drop. So that was to help a schema creation. And the structured format was to for the assessment at the end. And also somehow from this schema, they can easily make their hypothesis because they can see the group of instances that share a similar behavior.
So is the bias card actually the hypothesis?
Yes. The bias code, yes, it's hypothesis, the description with the evidence.
Okay, so that's that end of the sort of sense making process, right? So what about the data set explorer and the model captions? What do they support?
That's for instances and output state that we can easily explore are the instances they have.
Okay, so that's the first step.
That's the first step. This is the second step where they can make schemas. The box where they can drag and drop the evidence. So this
Okay.
both supports hypothesis and schemas.
Okay. Okay. Why only the first two stages of that sense making process?
For the editing tools, the input manipulation, they were based on the strategies we use in user-driven algorithm editing. Because in the user-driven algorithm editing paper, they discussed the sense-making strategies they saw in people in social medias or the organic editings, and one of them was to manipulate the inputs and see how the model changed. First of all the strategies were on comparing inputs and outputs. The first one was on manipulating input. The second one was to see a group of outputs and somehow compare outputs based on group level, so they could find more broader patterns.
Okay, so that kind of work was directly inspired by that paper and partly by the tools that they provided.
The sense making format, and we observed in our workshop.
Okay. All right. So I think one of the results that you have is the masking tool encourages visual kind of hypotheses, and the keyword tool sort of encourages hypotheses that relate to language.
Yeah.
Isn't that a little bit obvious?
Yes.
Am I missing something?
No, it's obvious, and I had this dilemma too. But at the end, I think it's not just that I think it's important that in an image capturing context, we have both visual and textual, and these are two modalities, and we should provide a way to interact with each modality for user. Like, I know that input manipulation leads to visual, but how and why? So the process is important. That's sense making for me. So when you make that modality interpretable and also or mostly interactable, it leads the user to that sense making to find those biases. I don't know if it's clear.
Yeah, okay.
I think one of the limitations in our work was that we didn't provide another condition that had two tools to see how the modalities interact with each other.
Yeah, I guess that would have
Yeah,
been sort of
very
like
interested.
the missing piece. Good. I don't know how I'm for time. I have one more question.
You're pretty perfect for time, so let's do your question.
So can I ask it? Okay.
Yes, please go ahead.
All right. So I think in your discussion right at the end, the sort of chapter where you wrap it all up, I think you make the claim that your work supports that positionality shaped the biases that people uncovered. And I was wondering where you've got that evidence?
Formulated that way. I think it was mostly a hypothesis rather than an evidence of my work. We had analyzed data, but I had some assumptions or some memories of people who their gender attitudes scores were high, and then they didn't find any biases in the model. So now I still don't have concrete, explicit results to motivate that. But based on all the literature that I read, I think it's a limitation in my work, and it's a very nice future work to work on.
Okay, great. I think that's me.
Perfect. So then we will go to Genoveva Vargas Solar, who is a chargée de recherche at the Université Claude Bernard in Lyon, and she's online.
Hello, thank you. Thank you for the work, and I read with a lot of interest your dissertation, and your presentation is completing what I understood from the dissertation. Of course, I have a certain number of questions, and I'm going to start with a statement you did more or less at the end of the presentation, saying that there are feminist approaches that are can be integrated in the work. And when we talk about feminist approaches, very often we explore power. And so my questions will be, will dig a little bit with you around the question of power. In the first approach that you have, it is users that are going to participate in the design of a machine learning oriented solution, right? And the idea is that these users are novice users, and together with experts, right? And I was wondering, how do these novice users deal with the power? You know, user experts tend to be, you know, the experts, right? So they tend to have a little bit of control, or a lot of control in what they think they should do. And then you have these users intervening in the design of a certain solution. Do you have a hypothesis of the profile of the experts who would be open to listen to users' suggestions during the design process?
I mean, that really depends on the institutions or people who are responsible of these systems. I think from my side, from human-computer interaction side, all we can do is to empower users to be able to understand the machine learning model, or to interpret it, to question it, or to audit it somehow, to come up with the problems that exist in the machine learning systems, and or also to surface their values, like that interaction between the user and the model. Where I can contribute is that interaction, to how make the model more open to critique, open to interpret. And this is the user side of a loop of that power dynamic. I think the other side is the institutions and the actual companies that are in charge of these systems. And that's not, I think I can't do anything about that. All I can do is to empower users to come up to make these institutions accountable for what they provide to the users. But the profile of those who listen to these users, I think I can't do anything about it.
Okay, well, maybe, I mean, your hypothesis is somewhere that you can, because you're imagining a setting, maybe you're changing the production model, which is right, where you have a kind of virtuous interaction with the I mean, between users and experts.
Yeah, awareness of the users that this interaction make them aware of the problem, so it make it more explicit about the problem when they know there is a problem here.
Right. And then I was interested, in the different phases of the design. At some point, data is kind of key. And I think that with your different tools, you show how to explore through data and evaluate through data and assess through data, biases, etc. But at the very beginning, for example, when you're cleaning the data, etc., you're even choosing which data you are going to use. Then users have a lot of a say in what the expert will do. And I was particularly interested in your opinion about sovereignty, data sovereignty. How can this perspective could be integrated in this collaborative design of the model and the model-oriented solution?
I think the solution first of all is on the human side, on the user side, that again there should be interactions that they can first surface their values to see. And I asserted in my thesis a lot that this value is bringing up through that interaction. Then after they have their values, then they should see what other values exist and whether they exist more diverse, sometimes if conflicts. And then there should be means that they can surface these conflict and diverse viewpoints, and then there should be tools they can communicate and negotiate about it. So then the important part is that negotiation, that dialogue between users to negotiate their values. And then there is the part for the machine learning system. I think in this case, we keep saying that machine learning amplifies shows and behaves in a way that is reinforcing the dominant way. But when the input that is going to the machine is an outcome of negotiation of all those conflict solving between users, then I think that it has less danger rather than that dominant values. So this is one of the ways we can incorporate human values.
And yes, sorry, continue.
I mean, from models, another interesting approach to show more possibilities rather than just one definite outcome. We can show more possibilities based on what inputs this possibility might happen.
Right, and then with respect to negotiation, well, you negotiate the design of the model-based solution is adjusted. And can you elaborate on the possible ways of making sure that the negotiation really was considered in the technical design process?
Making the outcome more transparent, like what I said, that maybe we should come up with ways that we show this outcome is based on these inputs with these weights from these people. I think the key here is transparency about how that outcome comes. I think that's that negotiation at the end, what outcome goes to the model, that outcome should be traceable back to who provided these inputs.
And the other question I have, of course, well, I completely adhere to this collaborative and negotiation-based approach. However, people that are not, acquainted with these perspectives and sometimes do not accept these kind of perspectives and are seeking much more like, performance at all prices and short time to market solutions, this kind of very extractivist approaches. Changing the production model has an implication, for example, in time to market. Throughout your study, did you consider doing some comparative analysis on how much does it cost in terms of time, in terms of human power, of human intervention, in a model where you allow users to participate, whereas in a strategy where the expert does everything and then users accept what they get in terms to the duration and of the final result production.
No, but I can imagine it should be very difficult. But first of all, we should realize who is interested to participate in such activity. For instance, I can give you an example. I came up with this idea that we can use collaborative interactive machine teaching in a content moderation for a Mastodon instance, because I realized these communities, there are people who are voluntarily want to do the content moderation without any machine learning systems. So at least there is some basic interest in them for the application. And those are people that might be interested to be the participant in a machine learning development phase. So I think one difficulty is to find people who are interested and have the motivation to do that. But for the time, I think it's not a 1 month, 2 months work. I think it should be a very long-term collaboration. Mm-hmm. And here, I think that one interesting thing would be to combine both CIMT with auditing, because it's not that all the community is interested to develop a model. I think there are very limited people who want to participate in the model development, but then on the auditing side, there are more people who can audit the model, and then they can use that audits for their models. Mm-hmm. So I don't know faster the.
Yes, I mean, it's a curiosity, since you have this running experiment with users, etc. So it might be interesting to compare, of course, time and performance is not the only reference, but say, okay, we are spending time in this negotiation and collaboration, but then users are happier, of course, of the results because they are closer to their expectations, etc. Try to also confront both approaches, since you already have one with actual users, right?
Yeah.
And I have another question regarding the other aspect, which is now you have a black box and you want to see whether there are biases within this black box. And in your examples, you address biases by considering that the users are acquainted to categories that they want to associate to bias studies. In your example, you used gender. Would it be possible to have like an intersectional approach and consider several categories and have a look and explore the collection with respect to several categories?
Yes, I think, but it would be interesting, and I bet they would find more varied and interesting outcomes, but still we needed to have a controlled study, and we needed a shared thing that we can compare both the groups and also other things. So it was a limitation that we needed because we wanted to see how different interpretation based on same bias might emerge. Or so we needed to compare many things that more varied variabilities would be maybe destroyed. But I bet if they were free or if they had, they didn't have a set data set, they would find way more varied and interesting outcomes.
And then since we are using models, could it be possible to teach a machine learning based system to help, I don't know, like an interactive way of digging into the data to see whether to discover biases or not, and help the users also discover and assess the level of bias of the data in the results.
Was it a question?
Yes, and whether it would be possible, or do you feel that it would be pertinent to use a machine learning model to help users to detect bias?
I think, yeah, but it can be used as a metric or just something to help them surface things easier. I think at some point we were thinking about providing a image generation model for them so that they can generate more inputs to prop the model.
Right. My question goes because, you know, it's having users really analyze the data and explore the data can be a little bit of a burden, you know. So
Yes.
trying to help a little bit. Okay, that was my last question. Thank you very much.
Perfect, right on time. So now we will go to Marianela Feliz, who is an assistant professor at KTH Real Institute of Technology, and she's also online.
Yes, thank you, Anastasia. I put the timer, otherwise I know that I will go over time. Behnoosh, thank you for this nice thesis and presentation. So my first question is about your motivations, basically, or your ambitions. So through the knowledge that you generated in this thesis, is your main ambition to influence the evaluation of machine learning models in the wild, or also their design? So basically, you are saying we need different ways. We desperately need different ways to evaluate them. But are you also saying that we need different ways to design them in the first place?
Yeah, for sure. If we could design them from the scratch with users, it would mitigate many problems. But with the current big AI companies, I don't know how feasible is that unless a community wants its own machine learning development.
And what would you center if you had to target both goals at the same time, design and evaluation?
Sorry, what was that?
What key concept or what key aspect would you center if you had to target both goals?
In an ultimate goal, both of them probably, as I said, that they can part of the community would design the model, and then the whole community can participate in evaluating the model.
Yes, sorry, I meant what aspect of design of these systems would you target if you had to fundamentally change their design, basically, if you see what I mean? I'm probing for something very specific that it doesn't come to you.
Then for sure the data set curation, what they choose and how they bring it with what label, with what values.
I was basically probing for an answer that would center interaction, because I think this is a concept that comes through all of your thesis. It's sometimes highlighted, sometimes a bit hidden, but I think that ultimately you're telling us that we need to center how to design the interaction, both to create the model, but also to audit it, to question it, to intervene it, and so on. I think you have a nice story here to tell about centering interaction. And then another question I have, you say at some point that we need to see how well the systems support people in their practices. So this obviously make us, I guess, all think of the role of qualitative assessment and also quantitative metrics. So after you have done your thesis and going forward, would you recommend that we focus on more complex metrics, richer metrics, or no metrics, basically qualitative assessment, and why?
I think I should start from literature. That I read many works on the qualitative perception of fairness, for instance, from the lay people, general people, and how they have different perceptions, but at the end, their perception is aligned with very basic fairness metrics like the book level metric, rather than all those complicated metrics in the quantitative measures. But still, I believe having a metric for a shared object for a shared object that they can build their understandings around that, critique it, or it's like a way to communicate with the model. That would be interesting, but still we should be careful not to foreground them based on that metric.
So you will go for both, basically, for as rich as metrics as we need, but also qualitative assessments, basically. Thank you. Then I was wondering if you could envision a version of Teach Talk for example, a sensitive topic, and or for a task where the labeling is more clearly subjective than the task that you had. And if so, if you could envision this, either sensitive topics or subjective tasks, are there design decisions that you would have made differently in your thesis if these were your contexts?
Probably yes, for sure. First, I would make more explicit documentation about who brings what's data, and also for sensitive aspects, I think the whole practices around care those are also important. So I think for that we should for the roles also. So participants should be they should be free to choose what and how they want to contribute to this development. If they want to bring data, they should be aware that they should have consent and be aware that what data they're going to interact with will be sensitive. And also, I think the documentation is important.
Yeah, I asked this because, well, partly I work with this type of topics, and partly because of what Genoveva was saying, like the more collaborative and the more participatory, the more burden of participation the users have. So in a sensitive topic, it might be that it requires a lot of emotional labor from them. And so that requires for even more expertise and care on the side of the experimenter or the person dealing with this sort of thing. And then I was curious for which scenarios or which contexts you would actually argue against a CIMT approach.
Not to have a collaborative workflow.
The scope of application of your approach, is it valid for any sort of learning system we want to build or evaluate?
I don't know. I haven't thought about it. In which context collaboration might be more catastrophic.
Nothing that comes to mind a priori that you're like, okay, no, there I don't go.
Yeah, it's interesting.
Yeah, I guess that if I had to answer that, I would take it one step back and say, well, any context for which I would argue against having the model the first place. like collaborative or not, there we should not build stuff like, in my opinion, in my positionality, recidivism risk and anything related to predictive policing or warfare. That would be a no-go to me. Let me see how I'm doing on time. Okay. So at some point you mentioned the importance of achieving critical user engagement. And I am left wondering, but is that enough? A tiny bit like Genoveva was also asking, like how do users gain agency in their negotiation when they are faced with strong power imbalances? For example, with a tool that they were not part of building and they are just users, basically. So I wonder if you're ultimately suggesting that users should also be product owners.
I think this is the primary goal of all these participations and empowerment.
Mm-hmm.
The
Yeah.
owner of the product is for community because it's their data, it's their practices, and it's working for them.
Yeah, exactly. My next question was going to be like, can AI ever be actually participatory if the community is not in full control of the model? Like, is there hope of calling it participatory and being real if they are not in full control? And I guess that we agree on that. Then I have another question on, is it really model behavior what you're referring to in your thesis? Or is it actually something broader than model behavior that also involves the user? Because it sounds to me that model behavior is still too model centric for the type of work you did and for the type of arguments you come with to this work.
Then I think interaction is higher than behavior because it considers both user and the model. So it's basically human model interaction.
Yeah. I don't know what would be
Yeah.
it just your thesis prompted me to think about that, basically. And then this is similar to a question asked before, but not exactly the same. So at some point when you cite Cambo and Gergel, you say that, yeah, it matters which perspectives are embedded in model behavior and which ones are left out. So I was wondering, is it a matter for you of enriching model behavior, basically embedding more perspectives in model behavior, or actually not, actually keeping the scope of the model as it is, but then recognizing there are many other components at play? And another part of the question is, does this difference matter and why?
Isn't both the same? I didn't understand what other components do you mean?
All the sociotechnical aspects that may not be embedded into how the model produces an outcome, but that still matter, like for example, how people interpreted it in the wild.
Yeah, this is where I wrote about model positionality in my discussion, that there is both the dataset positionality and all the people who curate this dataset or they are part of this dataset, the people who label this dataset, then the development part, like designers, developers, and then the positionality of the user who interact with it and how it interprets it. So there is the data set, the people who are in charge of model development, the model itself will reinforce or interact with all those standpoints, and then the user positionality who interprets this.
I think that where I was going with this is trying to problematize a tiny bit this type of arguments that ask for deliberately encoding values into systems. Like, for example, just to give an example, Sasha Constanza Schock in her book on design justice says that we should embed these values into the systems. And I have a bit of a tension here, so I wanted to hear what you thought about it. That's where my question was geared towards. And then one last question in the 2 minutes and a half I have. among your implications, you say we should let participants negotiate model behavior and teaching objectives. And here you actually mention some potential metrics, basically operationalizing broader concepts that we could, to some extent, quantify. But I was wondering if you see space for values that cannot be captured by metrics at all, or that if we try to capture them through metrics, we would do a disservice to the concept. And for those values, do you still see some way of formalizing their presence, but not through metrics?
I mean, yes, if metrics could capture all the values or the intersectionality or the conflicts, then we needed to have all these discussions. We could just quantify everything and optimize them. So there are many things that you can't measure with metrics, and this is why we still need qualitative perception of the people who interact with them. And also for the values themselves, I don't think we can quantify values, because values themselves don't make sense if the value makes sense into an interaction. Even for me as a human, if you ask me what are your values, I don't think I can make the values, but through situated interactions, I can surface my own values.
Yes, and yet I guess we all strive for building more just systems, and yet we cannot agree on what justice means or in how to, in a sense, operationalize it. Like, how do we argue that one system is more just than another? So I feel that we are in this trap into we don't want to quantify things that are actually human, social, temporarily, culturally situated, in a time and in a space, but at the same time, we want to have this as a moral compass, in a sense. So I was wondering what was your position on that, basically, yeah. I think I'm out of time, but if you want to add anything.
I just wanted to add something that for your question that when we should ask if we want a machine learning model or not. I was thinking about with myself, I was thinking about all those disagreements that user can negotiate and surface and then convey to the model. Then I myself arrived at the point that then why we need this model if there is all these disagreements about people about a decision like the compass risk assessment, etc. So I think it's very based on the human still rather than the model or the technical aspects.
Thank you.
So I think we can, if there are any further pressing questions from the members of the jury. You're good? Okay, so then what we will do, because I know there's a strong constraint from one of the jury members, maybe we can go through to the supervisors in case they have questions or have a comment to add. So we will start with Jean-François, who's chargé de recherche at l'Université Paris-Saclay.
Yeah, thank you. Yeah, I'm not going to ask any questions. We discussed already enough these past few days. No, I just wanted to thank you for all the work that you've done in the past 3 years. It's been a pleasure to work with you. It's great to see the results today of this defense. It also, I think your thesis addressed a number of topics that were very important to me around machine teaching, and I think it's nice to see how you changed also over the thesis. Yeah, and actually in the first study we had something where we decided to simplify the problem and use only accuracy in the instruction to the participants, and the notions of diversity and the importance of representation in the data came very strongly. And I think it led you to take a very different direction in the middle of the thesis, which was pretty difficult because it opened a very large area in terms of related work around fairness, around bias, and diversity. So it was courageous to take that direction, and I think it's been very stimulating, and I see that it's leading to even more interesting questions now. So yeah, if I had maybe one question, but I mean we've done more like lab studies and your PhD, and I think you're really striving to have more like situated context. So what's next in terms of the methods and the context where you would like to
Yeah, I really would like to finally work with the community in a situated context and with more exploratory, more reflective and first method overview over the whole process, and probably feminist approaches to this whole process, especially based on all the literature review that I've done. This was always my ultimate goal, but I was always confined to level studies, control things, narrow things. So I can't wait to do that.
That's good. I'm excited to see where it leads you in the future.
And we will then move on to Baptiste Caramio, who's chargé de recherche at Sorbonne University.
Okay, thank you. Yeah, I would like also to first to congratulate you for this presentation, which is very interesting. Always, even if it's the third or fourth time that I'm looking at it, it's already I'm still learning things. So yeah, that's so I'd like to congratulate also for your work that you did during these 3 years. And yeah, it was very interesting to see how it evolved over these past 3 years. So I was very happy to be part of it. So thank you for contacting us when you were a master student and started work with us. I think I will say the same thing that Jules. I think your PhD work addressed very important topics, very timely. Collaboration, participation, auditing with machine learning. So I think this is very important works that you have done. So you must be proud of it. And I think you have actually paved the way of very important research direction. I think regarding the first study, so you work with the collaboration in machine learning development, but you are going also towards this collaboration. So you show that designing CIMs like collaborative and interteam teaching is not obvious, and eventually people were maybe more cooperating than collaborating. So there are many things to look at, many challenges here to make. It's not really to make like also to study collaboration and see how they are engaged and involved in such a task, which is not also a very common task for them, but that can have actually very important applications. So I think this is you started with a very interesting work and you built a very interesting platform, TeachTalk, that can be used, I guess, for further research direction, research topics and projects around this idea of collaboration and participation and so on. There is really a lot of things to look at. And also in your second study in auditing, I would be, for instance, curious to see how people will review one like the other bias cards, like how you basically people together, you know.
Yeah.
It was very individual, and I was like, yeah, listening to you again, it's like, yeah, actually how people would maybe audit the bias cards of the other. So here also there is something to very interesting, I think, to look at, like linked to group work. So I guess, yeah, so I guess your thesis also demonstrates how your interest evolved from study 1 to study 2, from machine teaching to editing, and that has been commented already, and now towards more maybe political questions using feminist approach, and also very interesting. So one question for you. Trying to to link the two studies a bit more tightly. You presented a sense-making framework on for the auditing, and it was more individual task, while the first study was more focusing on collaboration. So I was wondering, do you see this framework that you use of sense-making applicable for collaboration? Or do you see that, or do you think that it should be extended, like this framework of hypothesis, schema, formation of schema and hypothesis? Do you think this applies? We can use it now to do, okay, let's do a collaborative algorithm auditing, or it needs to be extended somehow? It has limitation.
I think it can be incorporated directly because in collaborative interactive machine teaching, from the reviewing process, we got interested to go to auditing, and all those interactions we design, all the auditing tools we design are very proper for the reviewing activity in collaborative interactive machine teaching, and also the audit cards can be easily become shared objects for people to see their different interpretations, to see those values that they should at the end discuss together. So I think it can very easily combine together.
Good news. Thanks.
And last, we'll go to Mr. Behnoosh, who's a professor here.
Thank you. So first, I would like to thank the jury members. Thank you very much for your work. I would like to thank Jules and Baptiste also to include me in the supervision of the PhD. And so it was really a pleasure to work with you. I will say that you are really hardworking and tenacious person. So you have really made many things. And on my side, I'm more ML expert, I would say. So I'm used to design algorithm and evaluate them with numbers and quantitatively, etc. And I see, and I can say you that in your work, it was very, very difficult because human is in the loop and you have many, many things to try to sort, organize, structures, the bias cards, etc. There are different types of different point of views that are possible. So it's a very big work. So really congratulations for this work. And yes, I think you will have really good skills. I think that not anyone could do what you have done, because there is computer skills, but also sociological aspects, etc. So it was very, very interesting also for me to work with you on that topic. Thank you.
Perfect. So I think we will conclude here. It's okay, I don't have to ask a question. I will ask you during the poll later on. And so what we will do now is the jury members. We will move to another room, if I understand correctly. Is that right?
Yeah, we can the salle.
You have reserved another room. What about the remote members? They have a specific link, but they can join you.
Not yet, but maybe I can send
Yes,
I
maybe
can
we
send
can
a new link.
and send me one as well, so I can moderate.
So we're getting another link, right?
So we will send you another link to connect.
Okay, so we're not breaking the room, no.
No, we will not break in this room.
Okay.
Okay.
You can stop presenting.
Incredible. Wow.
Mics are off.
You should
So
be
this
hearing
will
us now.
all be here. If you're connected to Zoom, well, clearly everything went very well. As far as it's clear to you. So maybe you can, I'm not sure if you want your jury to be there as well.
Yeah, sure.
So maybe some of your colleagues can take pictures.
Should I? Wait.
Thank you all for coming back. So first of all, congratulations. So what we will do now, it was a unanimous agreement to grant you your PhD thesis. So we will read to you your report, and then we will take your oath in front of your peers. Yes. Okay. So Behnoosh MOHAMMADZADEH, close. Yes, defended her thesis, Construction of Model Behavior by Novices through Interaction with Machine Learning, which lies at the intersection of the domains of human-computer interaction, sociotechnical studies, and artificial intelligence. As everyday use of machine learning by novice users becomes commonplace, her presentation highlighted the importance of empowering end users to interact with AI models to shape an outcome. The presentation was clear and well-paced, providing a comprehensive overview of the thesis with visuals that complemented her discourse. Behnoosh presented in a cohesive way the pertinent results of her empirical studies that investigated how to best support model interaction both during training and post-deployment. She was pedagogical, explaining her contributions and novel outcomes of her work. She was able to provide evidence of the complexity of the conducted work and that combined substantial technical and empirical effort and skills. Behnoosh gave pertinent and honest answers to the numerous and challenging and open-ended questions of the jury. She demonstrated a mastery of the topic, providing well-thought answers with examples of her own work. We have to rephrase this here a bit of English, referencing previous work, her examples, and thoughts of future research directions in her answers. For all these reasons, the jury proposes unanimously to grant her the title of Doctor in Computer Science at the University of Paris. Congratulations.
I have a screenshot.
You have a screen.
Very practical.
In the presence of my peers, with the completion of my doctorate in informatics, in my quest for knowledge, I have carried out demanding research, demonstrated intellectual rigor, ethical reflection, and respect for the principles of research integrity. As I pursue my professional career, whatever my chosen field, I pledge to the greatest of my ability to continue to maintain integrity in my relationship to knowledge, to my methods, and to my results.
Perfect. So you're done. So should we say goodbye maybe to your remote jury members that we see here?
Yes, enjoying the food and the wine for us.
Yes, enjoy the cocktail. Yeah.
Congratulations.
Thank you very much.
Congratulations, Behnoosh.
Thank you very much.
Thank you very much.
Bye.
Bye bye.